and select the difference, okay, divided by RS. So this is the formula for surface based aridity index formula, and rename it, okay, and make the classification, okay, and print this collection. And this is the legend, simply add the legend of the title, but we try to add here chart. Okay, so this the legend code is done. So now for the list, we simply put the make the list. Suppose I need the result 2000, 2001, 2002, 3, 4 up to 2019. So now we are just the LSS summer main. Okay, no, it's not this it's not needed. It's the another part. It's not here. So in this time we are just not we work with the summer or any season. We just take the data 1 year. Okay. So now create the list. So just call the SBI collection and select the SBI. This is the band name of this collection. Basically it's come from our band. So his band I created in here. He just come from here. From the SBI collection. It just come from here. And select the band name SBI class to list. So just I export every year SBI map. Okay, so for that I simply create a loop. So it's called the for loop function. So in this case it's help you. Suppose for loop, suppose I want to export all of map at the same time. Okay, we can simply apply the for loop function and export all of yearly surface based aridity index map, export at the same time. If you check here in my tax tab, it just show the result. You can see all of year, okay, at the same time. Suppose 2001, 2002, all of aridity index map easily export as a GeoTIFF file format because I apply the for loop function. So for the for loop, you can see just I put the for function and set a condition. So in this condition, initial it will start from the 0 and less than n and increasing 1 by 1. Suppose 1, 2, 3, 4, 1 plus plus increment. Suppose 1, then 2, then 3, then 4, then 5, look like this. And we can simply apply the ee.image call list. So this collection list, it's come from here. Okay, SBI collection. And here you can see two list n. N basically stored the this your collection. Okay, collection size. Okay, it's come from this n. So we define it, and you can say I just add the code export image to drive. So I put the this is my image and a subclass. Okay, and then we simply export all of those at the same time. So this code you also try to apply in the another image collection. Suppose you just create the 20 years NDVI. This 20 years NDVI map you just create, and now you want to export all of map at the same time. So you also try, because there are a lot of uses in the for loop function. At the same time we can easily add all of layer. At the same time I can export all of map. At the same time I can print all of chart. Okay, there are a lot of uses in Google Earth Engine for the for loop. So same way you try to create the for loop and then check what happened, it will be work or not. So in this case you can see image ID. So this image ID basically it's come from this variable. If you check, it's come from here, and it so 1, 2, 3, 4, 5, 6 up to all of image. Okay, it's come from in here, and also scale max pixel. So this is the for loop function. Okay, it's help you to get all of GeoTIFF file at the same time. We can get for all of years from 2000 to 2019. Okay, then simply run. And you can easily get this type of result. Okay, simply run and you can easily export the GeoTIFF file format so this is the power of for loop function. We can also use it, and not only for that, any code we can use it to get the result. And now for the chart, you can see LST day time series chart. So just apply the LST collection AOI and select the band LST day 1 kilometer. Then we can get the yearly chart LST day, then LST night and difference. Okay, Then SBI chart. So all of chart we simply create it in here. If you check, so SBI class value chart, this is the chart for SBI value, RS value, okay, difference value, LST day night 1 kilometer, LST day 1 kilometer, okay. So all of chart easily visualize in our map. So I will send you this code. You also try to work with for some countries or also some specific continent. Okay, suppose only for the Africa, only for the South Asia or Middle East or North America, South America. Okay, and try to and read some this paper. I also send you that. Then try to identify the surface based aridity index and monitor the drought condition. Okay, anyone any question you can ask me please. Any question? Hello, can you hear me?
Yes, we can hear you. We are getting it to review the codes.
Okay. Okay, no problem. I'll send you all of materials. You try to apply and then face any problem, also inform me. Okay. So this is the way for surface based aridity index and monitor the drought. And we just also follow this paper. So I'll just send you this type of reference link also. Yes, please.
Yeah, but for smaller study area, we have to use the land search rather than the modis.
Okay, so in this case, I think we are develop this type of things help of the modis reflectance band. So it's also better to use the big study area. Then we find out the more better result. Suppose you can work only for the continent, suppose Asia, South Asia, okay, and also for you can also merge some different countries. Then we find out the more better result. Basically, this paper it's developing this method based on reflectance of modis. Okay? For aridity index, just apply the aridity index and then identify for the drought for the globally or big study area. Okay, or you can also try for countries, suppose some your countries or some any big study area. Okay, then we find out the more better result for this drought. Okay, you can see that also
like a whole like a whole country boundary, right?
yes, then it provide the more better map we find out. So I'll just send you this link also, you can try to read, then you can get a more better idea about that. Okay, so now we talk about the last topic, land use land cover classification using Python. So previous class we discussed about that how we can easily upload the image and how to read the image, how to add the image band, or how to display the image, how to display the training sample, okay, or how to display the shape file, okay, for our training sample. So here I have already have this type of shape file and I already imported. So now I try to explain this code. Okay, so you can see this is our image and this type of red color indicating about the build up area. This type of blue is that your water body. Then green color is indicating about the vegetation and yellow color indicating about the build up area. So now I want to use this type of data and then work with my machine learning model. So first of all, it's a samples. If you check the samples variable in our code, where is the samples? Yeah, so this is the samples. Yeah, this is the samples. Okay, samples basically stored this file. Okay, all of file you can see samples. It is stored my file. So basically this file is the shape file. It's samples. In the samples, we find out the one file or one column. It's called the geometry. If you check, it's called the geometry. Geometry basically your latitude and longitude. Geometry column stored latitude, longitude. Okay, so just I work only for the geometry. So just I copy the geometry column and also call my samples. Basically this variable stored the samples. Okay, just I call the samples and call the column of geometry. So then when I run the code, then we can get this type of point. You can see the longitude, latitude, and it's a geometry. Okay, so we find out this type of point. So now from this point, I just create a array. Okay, suppose in this case, if you check for point in sample geometry, x and y, x basically longitude, y basically latitude, and we create the band value. Okay, so we just extract the band's pixel value from our every points is extract the band pixel values. So this function, first of all, you can see the array sample. So array sample, I just make a list, empty list. I just create the empty list. So this list, I want to add the band sample, band pixel value after extracting the latitude, longitude value. So it's just I put the empty. There is no value. So this array sample further I also use in here to store the band value in this array sample. So just I simply create a blank or empty list, and then I simply apply the for point in samples. So for point in samples from geometry column, and I create the for function and apply the x and y. So x basically for point x y longitude, and for y x y latitude. So row and column src basically this variable stored the image. If you check the src, what is the src? When I open the image, then we just put the variable name is the src. So src, it just stored our image, this image, this TIFF file image. Okay, so just I call the src. So from this image I want to extract the pixel value. Okay, so every band's pixel value. So further you can check, just I simply take a blank list, and then every training sample, basically x and y, longitude and latitude, I just stored the your band values. So for that band values, I just simply put here the for in range and src stored our image, and I count band value from the src and stored the row and column. And then this array sample which I already created, this function I just connect with the band value. So now all of band values is stored in this array sample variable. It is stored in here. Okay, so now further, okay, so let me run the code from start, then it will be more better. Just a minute. So let me just install it. Just run. So this is the one problem to install it this type of library again and again in the Google Colab. But when you work with the Jupyter Notebook, don't need install again and again, because the Jupyter Notebook is the locally we can run all of, but in Google Colab we need to install it the package all time and then work. Okay, then we simply import all of package. Then okay, we need to connect our Google Drive. Okay, it's already connected. So just path, just I simply run the code. And then I just put the src variable and help of Rasterio Python package. Just open this image, run it. Then src read. So just I read the information for my image. So we find out this type of array, reflectance value for this image. then try to check the shape. We find out the 12 bands. Then this is the height and weight we find out. So this bands, this is the bands, we just apply the transpose. So transpose, I just make the serial 1 2 0. So it's the 0, then 1, then 2, but I set 1 2 0. So now 1 is the height, 2 is the width, and 0 is the band. So I just simply change the serial or sequence and run the code. So now I want to display the red, green, and blue. So this is the first step or first serial for height, then width, then put the band number. So height, width, band number 2. So then height, width, band number 1. So now red, green, and blue, and create. And then I want to create the mainly make the composite or band, just use the np array dstack and put the band combination red, green, and blue. Then display this type of image we find out. Okay, so we find out this type of red, green, and blue. Okay, now it's okay. Yeah, okay, thank you. So now you find out this type of image. Okay, and this is my another, this it basically it's provide you the shape file, your training sample, basically water or different types of training sample, just I display. So then we find out the class number, sample, and also get all of band pixel value for this point. Okay, and then I just keep the same coordinate reference system, for the sample and image. So just I take the variable samples and two CRS, put the same, okay, and then print the sample CRS and print the image CRS. So sample CRS, mainly coordinate reference system of sample, and coordinate reference system of image must be same. Okay, otherwise it creates some problem. So your sample CRS and also your point CRS, okay, your image CRS coordinate reference must keep the same, otherwise this code is not work. Then we simply add the color code, so display the training sample point. Okay, now run the code, then we can easily find out this type of color code. If you check, so now it's added the image and also added the training sample point. Okay, so now we find out this type of map. If you check, we find out this type of coordinate. Okay, it's work for the water body training sample. This type of point for build up, red color, green is the vegetation, okay, and yellow is the barren land. So now it display this type of things. So now I try to just from the shapefile basically stored in the samples variable. So from this variable I just call the column of geometry. Okay, then I can get all of geometry, point, latitude, and longitude value. And now I want to extract the band pixel value or bands value. Okay, for this just use this port. Just take a empty array sample variable, and for every training points, basically longitude, latitude, I just extract. So now let's check and also check the shape. So we find out the 140 training sample, 140 training sample, 12 bands. Okay, 12 bands. So now I want to apply the machine learning. So for that I need to call the scalar model test selection. Okay, this is one kind of scalar model selection, and I import the train, test, and speed. It's one kind of library. Then scalar matrix to check the classification report. So this is another scalar matrix. Then Cohen coefficient, basically kappa accuracy or overall accuracy or F score. We just try to check using this library. Then scalar matrix, confusion matrix to create, and scalar processing we can apply the level encoder library. So now just run all of packages. Okay, it's okay. So now just run the code. I just call the samples. Sample is stored my all of this my shape file. Okay, it is stored at the sample C. this column stored the all of water, all of samples, barrel and total 140 sample. Okay, and if I run the code again, and this type of level encoder, so now I can see find out the value. So 0 is one class, 1 is another class, 2 is the another class, 3 is the another class. So in my total class 0, then 1, then 2 and 3. Okay, total 4 class I try to classify it. And then I take the variables suppose xtrain, xtest, ytrain, ytest, and then apply the train test split function to use the 70% data to train our model and 30% data to check our validation or accuracy. Just I put the x and y. So here you can see x basically it's our training sample, bands value, and y is the class. Okay, class basically you can see this is the y value. Y basically 0 is one class, 1 is another class, 2 is another class, 3 is another class, and x basically it just come from your, you can see 140 training samples point, 140 samples, 12 bands pixel value. Okay, we find out the x. So simply apply the x and y. X basically bands pixel value, y basically class 0, 1, 2, 3. So now test, I take the 70% data. So now create this model. So this is the model. So this model I want to apply mainly gradient boost classifier. So just I call the xgb. So it stored the gradient boost classifier. If you check the first line of code where I import my library, I already imported one library. Where is it? Yeah, so you can see xgboost. So it's one kind of Python package. So it stored the gradient boost algorithm. Okay, so just I already imported. So just I call this package. Okay, and from this package I just call this gradient boost classifier. Okay, just a minute. So the gradient boost classifier have some different types of argument. Okay, so let me show you this type of argument. Let me open from the Google, just a minute. So you can see this is the one kind of algorithm, gradient boost classifier. So here we use some argument. So you can see the parameter, loss, learning rate, n estimator, subsample, criterion. Okay, mean sample split, mean sample leap, mean weight fraction leap, max step, mean impurity decrease. So this type of things you can easily learn the theoretical part. You can see not only for the gradient boost, random forest, different types of algorithm they are also put, and it's come from the sklearn package. Okay, so if you check the code, so here we put the objective multi shop problem. Okay, so we put this is our objective, and random forest 48, then verbosity 3, and we put the estimator 500, max depth 10. Okay, so all of argument, learning rate 0.01. Okay, so we create the model or train our model based on this algorithm. So in this algorithm we simply set you can say normal random state 42 and multi swap problem. So basically this objective, when you want to identify for multi class, suppose more than one, then we try to apply the multi swap prop. It's one kind of objective. This objective mainly find out the classification for the different types of classes. Okay, then also number of estimator, basically 500. So basically this 500, it create the total 500 trees. Every class create the total 500 trees. Then max depth, also number of thread 8, and learning rate 0.01. So you can also read this type of things from here, then you can get the better idea this type of theoretical part. Okay, you can see the verbose. Okay, basically it's enable the verbose output. If I then one, then it's print the progress and permanence once a while. Okay, so you also try to read this type of theoretical part from this website. Okay, then you can get the more better idea about this argument. Okay, you can see the max depth, maximum depth of the individual regression estimator, mean sample length. Okay, mean sample split, n estimator. Okay, the number of boosting steps to perform. Gradient boosting is a fairly robust to overfitting. A large number usually result in performance. Learning rate. Okay, so this type of argument you can simply read from here to get the more better idea. Okay, then we simply use here. You can see this type of argument we need for the gradient boosting classifier. Okay, so this is our algorithm. So simply run this algorithm. It's also okay. So now we try to fit our model. Okay, so just I call my model and fit with our training data set, X trend and Y trend. So now run the code. So it also okay, there is no problem. And it create, you can see. So now further we check our accuracy of our model. So we find out accuracy of training set 100%, and accuracy on the test set 98%. So we find out that 98% is our accuracy, overall accuracy. Further, if you want, this is the train set accuracy, then check the prediction accuracy. Just apply the model and predict the X test. So now run the code. And now try to check the classification report. So now we find out, you can see the all of accuracy, suppose precision for 0, 1, 2, 3, it's the different classes. We find out the different F1 score, or support or accuracy, we find out the 98%. Okay, and further just run the code and display the map. Then we also create the heat map to represent the mainly confusion matrix table. You can see for the water body, vegetation, barren land. Okay, so we find out this type of things here. You can see, so it's one kind of confusion matrix table. Okay, we already know about the confusion matrix table. Basically suppose you can see how many pixel mix with the other pixel. So you can see, or you can find out the problem only for the one. So in the 6 we find out the correctly classified pixel 6, and one pixel it's come from the another class and mix with the vegetation. So that we find out this type of accuracy. Then we just display the prediction image, mainly land use, land cover, and predict the image shape. So we find out this type of shape and display the prediction image. So now it create the array prediction image. We simply apply with our model. So this variable is stored our model. So this model I want to apply on the prediction image land use, and then it create this final land use, land cover map. So it's working. And now just reshape and display the image. And so now you can find out this type of map. Okay, land use land cover map. We find out water body build up. Green is the vegetation, yellow is the barren land. Okay, so basically this is the process. We can just use this type of process and make the land use land cover classification map. So I also send you this code. You also try. Okay, suppose you can simply download a satellite image and also download the training sample as a shape file. Then try to implement this type of code. Further face any problem, they also guide you how we can easily apply the more better. But this is the process. So in this time, not only for boosting, gradient boosting, we can use different types of model. Okay, so simply change the model in here. Okay, so you can see it just show the I call the XGBoost classifier. But you can also apply different types of model in the Python, and you can easily visit this website. You can check this website. So here you find out the lot of model. You can see the random forest classifier. So it's one kind of model. So you can easily apply this model with your land use land cover classification and make the map. Okay, mainly only for the machine learning. Okay, you can also apply. So I also send you this code. You also try to practice. Okay, and if possible, you can also download your satellite image for your own study area, and further you can also work. Okay, so now talk about the problem solving. Anyone any problem for the previous class? You can also share with me. Yes, please. Any problem for previous classes? Okay. Anyone? Can you hear me?
Yes, we can hear you.
Yeah. Yeah. Any problem for the previous classes or everything is good?
Well, the one you shared, it was from the LST. I need to correct that. There is a problem with the Rossley border, but I need to look at that one again. But let me clear the one that you shared today, tonight, and I will revert, please.
Okay, I will send you the new code link for the LST and NDVI monitoring using Landsat data. So you try to follow this way, so it will be more perfect. I think. Yeah, no problem. We can easily make the one. Okay, so no problem. Okay, so no problem. I will send you all of code for today's session also. You try to practice. Further, if there's any problem, then I'll also guide you. Okay, inshallah. And next class will be held on the next week. Inshallah, we'll meet and discuss about the further topic. Okay, thank you. Have a good night. Okay, bye.